Hi, and welcome to another Dech Academy video. Here I have question 15 of the June 2013 Waec Maths exam. And it says, if in the diagram below, so that's this polygon diagram here, PRST is a square. If the side PQ is 24 centimeters, so that's the length of the side PQ, 24 centimeters, and the side QR is 10 centimeters, and the angle PQR is 90 degrees, which has been made obvious already by the right-angled sign here, find the perimeter of the polygon PQRST. So the square PRST and the polygon PQRST, so it's the whole thing. So let me do it this way. The square is obvious, but the polygon is this. Or rather, it's hard to draw a straight line, I'm sorry about this. PQ, R, S, so PQ, R, S, T. So you can compare this with this and see that PQRST is the polygon I'm referring to, and this is PQRST. PRST, the square, is very easy to see. What do you know about a square? You know that all the sides in a square are equal. So if I said let PR equal x, for instance, you will know that this will now be x, and the length of PT will also be x, the length of RS will also be x, and the length of TS will also be x because it's a square. So if I remember, the question says find the perimeter of the polygon. What do you need for the perimeter? We need to know the length of the sides surrounding the we need to know this length. We need to know this length, which we're given. We need to know PT. We need to know TS. We need to know RS. Now, from what I've just shown you, PT, TS, and RS are all x. So all we really need to know is x. And we can determine x from this triangle PQR using Pythagoras' theorem, as I'll show you. Once you have a right angle triangle and you're seeing sides, you have to find a missing side or a missing angle. For sides, you have to find a missing side, or you need to find a missing side. You should always go to Pythagoras. So we're given this as 24, this is 10. I've defined this as x, and if I remember here correctly, this is P, Q, and R. The side opposite to the right angle is always the hypotenuse. So, and that's always the longest side of a triangle, if you remember from your lessons. So opposite to this right angle is x, and that's the hypotenuse. Hypotenuse, just so you know what I'm talking about, hypotenuse. And what is Pythagoras' theorem? If you're given a triangle, so I'm just drawing a weirdly shaped triangle. Actually, let me draw the same shapes for consistency. Well, close to the same shape anyway. Given a triangle, A, with sides A, B, and C, the length of the hypotenuse squared is equal to the length of the other side squared. So if you know, wow, what did I just do? If you know 2, you know the third. If I know the length of B and C, I can determine the length of A. If I know the length of A and B, I can determine the length of C. If I know the length of B and C, I think I said that. If I know the length of C and A, I can determine the length of B. So once I know 2 sides, I can find the third one using Pythagoras' equation or theorem. So you always need to know 2 sides to find the third. So remember this. In this case, we're given 2 sides, right? We're given PQ is 24 and QR is 10. So applying the rule, the hypotenuse, as you can see, is always the side opposite to the right angle. In this case, that's x. So x squared must be equal to 24 squared plus 10 squared. Therefore, x squared is equal to 24 squared, which is 576. 10 squared, 100. Therefore, x squared is 676. So the perimeter, as I mentioned earlier, is the sum of the length of all the sides surrounding the polygon PQRST, because that's the perimeter we want. we were told to find. You see from the question, find the perimeter of the polygon PQRST. And I mentioned that all we needed to do was find x, and we're done. We just need to add the sides together. Now we know x. Well, we know x squared. Taking the square root of both sides, you have x equals square root of 676, which is x equal to 26. Another way to approach this problem would to be from this line, from here. You could have said, well, I have x squared and I want to go to x. I want to know what x is. What if I raise x squared to the power of half? And I do the same thing to the right hand side. Raise 676 to the power of half. What do I get? I get x from this using, well, I get x raised to the power of 2 times half using the laws of indices, a particular one in fact. And I get the square root of 676, which is x to the 1, it's root 676, which means x is 26. Let me just quote the law of indices, and the exponent law I just used. I mentioned it in the previous video, but just for those of you who didn't watch it. The law is as follows: a to the n raised to the m is a to the n times m. As you can see here, x to the 2, all raised to the half, is x to the 2 times half. How did I know to do this? I know that, as I mentioned in the previous video, if you have, say, a to the 1 over any number, say 2, in this case, raising it to the denominator of the power. So if the power is in form 1 over 2, 1 over 3, you raise the whole expression term to the denominator of the power, in this case 2, to the denominator of half, you always get a. You always get the base. Don't worry about this in too much detail. From here, x squared is 676. Just take a square root of both sides. You get x equals root 676, which gives x is 26. It's as easy as that. This would be complicating it, but this is just showing you how the laws of indices could have been used. But the easiest way is just to go via this route. Now we know x is 26. We need to ask ourselves what the perimeter of the polygon is. As you can see, we have 24 here and 10. So adding all the sides, perimeter, let's call that PER, is 24 plus 10 plus x plus x plus x, which is 24, or 34 rather. 34 plus 3x. X plus x plus x is 3x. Therefore, since we now know that x is 26, 34, parameter is 34 plus 3 times x, x is 26. So we now have 34 plus 100, plus 3 times 26, which is, I just have to do this in my head, 3 times 6 is 18, 3 times 2 is 6, 7, which gives you 112 centimeters. So sorry for this bit being a bit rough, but that's all it is.